In 1995, there were 51 kakapo left in the world. Not 51,000. 51 individual birds, and every one of them had a name. That is not sentiment. It is a measurement. When a species falls low enough that the people trying to save it can name every living member, keep a file on each one, and know which bird is related to which, the species is no longer a population. It is a list. In 1995, the entire future of the kakapo was a list of 51 names scattered across two small islands at the bottom of the South Pacific. The kakapo is not an ordinary parrot. It is the heaviest parrot on Earth, and it cannot fly. A large male can weigh close to 4 kilograms, far too heavy for its wings, which it uses only to break a fall. It is nocturnal. It smells faintly sweet, like old honey, a scent that helped it find mates for millions of years, and then helped introduce predators find it in a single night. And when a kakapo is frightened, it does not run. It freezes, and it trusts that staying still will keep it hidden. Against a hunting cat, that instinct is not a defense, it is an invitation. For a long time, it looked as though naming the last birds was simply keeping a record of an ending. But the strangest part of this story is not how close the kakapo came to disappearing. It is what happened when people finally started to win and discovered that their own help had quietly pushed the species in a direction that could have finished it anyway. Take 1 second to subscribe before we dive in. You will not want to miss where this one ends. To understand how a bird ends up as a list of 51 names, you have to go back long before 1995 to a country with no ground predators at all. New Zealand broke away from the other landmasses tens of millions of years ago, and it drifted into the ocean, carrying almost no mammals. For the birds that lived there, this changed everything. On most of the planet, a bird has to stay light, stay fast, and stay alert, because something is always trying to eat it from the ground. In New Zealand, nothing was. So the birds there did things birds are not supposed to do. Some of them gave up flight. Some grew large and heavy. Some began to nest on the ground and forgot how to be afraid. The kakapo went further down this road than almost any other bird. It became heavy because it did not need to fly. It became nocturnal and slow because nothing hunted it in the dark. It bred in a way that made sense only in a world with no predators and no rush. And for millions of years, this worked. The kakapo spread across the forests of the 3 main islands in large numbers. It was one of the most common birds in the country. Its way of finding a mate tells you how safe that world once was. In the breeding season, the males climb to high ground, dig out shallow bowls in the earth, and then do something no other parrot does. They inflate their bodies like a balloon and produce a deep, low sound called a boom. The boom is not a squawk or a call. It is a slow pulse of sound so low that it travels for kilometers through the forest and across the valleys, night after night, for hours. A male can boom through most of the night for weeks on end, waiting for a female to walk in out of the dark and choose him. In a land with no predators, broadcasting your exact location all night long is a perfectly good idea. Once cats and stoats arrived, it became a way of ringing a dinner bell in the dark, every night, for weeks. Then came people, and the animals that traveled with them. The first arrivals brought the kuri, a dog, and the kiore, a small rat. Both ate kakapo. Centuries later, European ships brought worse. Larger rats, cats, and then stoats, a fast and relentless hunter released to control rabbits, which promptly discovered that flightless ground birds were far easier prey. For a bird that freezes when afraid, nests on the ground, and gives off a strong scent, this was not a challenge. It was a slow execution carried out across the whole country. The kakapo vanished from one region after another. By the late 19th century, naturalists were already writing about it as a bird that was disappearing. One of them, a man named Richard Henry, saw what was coming and tried to do something that would not be attempted seriously again for another 100 years. In the 1890s, he moved hundreds of kakapo by boat to an island he believed was safe. Then stoats reached the island by swimming, and within a few years his birds were gone. He had understood the answer decades early and watched it fail in front of him. By the middle of the 20th century, many people believed the kakapo was already effectively extinct. Occasional searches turned up nothing, or turned up only old males calling in the dark with no females left to answer them. For a while it seemed the species was down to a handful of aging males, which is not a species at all. It is an echo. Then, in the 1970s, searchers went into a remote and rugged part of the far south, and they found something they had almost stopped hoping for. A population that still contained females, birds that could still breed. It was small, and it was in trouble, but it was alive in the one way that mattered. And this is where the second predator problem appeared, one that had nothing to do with cats or stoats. It was inside the kakapo itself. It was the way the bird breeds. The kakapo does not breed every year. It breeds only when the forest tells it to. In the southern forests, a tree called the rimu produces fruit in large amounts only in certain years. Not every year, and not on any schedule people can neatly predict. Some years the trees carry almost nothing. Then, every few years, they produce an enormous crop all at once, an event called a mast. The kakapo has tied its entire breeding cycle to this event. In a heavy mast year, the females breed. In the years between, most of them do not breed at all. This is the forest fighting back, in the most literal sense. The recovery of the kakapo was never going to run on a human timetable. It runs on the schedule of a tree. People could protect the birds every single day of every single year, and still the population would sit almost still, waiting, until the rimu decided it was time. When the trees masted, there was a sudden chance to gain ground. When they did not, there was nothing to do but keep every bird alive and wait for the next one. That alone would make recovery slow. But the kakapo makes it slower. The females nest on the ground and leave the eggs to go and find food, which means every unattended nest is exposed. A large share of kakapo eggs are infertile to begin with. Chicks are few, and they are fragile. A single female might raise only a few chicks across her entire long life, and kakapo can live for many decades, so the arithmetic of recovery is measured not in seasons but in generations. So by the 1990s, the plan became clear, even if it was enormous. Move every surviving kakapo to islands that could be completely cleared of predators and kept that way. Guard those islands as if the species depended on them, because it did. And then help the birds breed as hard as the rimu would allow. Moving the birds at all was an operation in itself. These islands sit in cold, rough water, and the survivors were spread across difficult country. Birds had to be found in the dark, caught by hand, checked, and carried out, sometimes by boat and sometimes slung under a helicopter in special boxes, across open sea to their new homes. For a species of a few dozen individuals, every single transfer was a risk taken with a measurable slice of the whole species sitting in one crate. Every bird was fitted with a small radio transmitter, so its location was known at all times. This is not an exaggeration. Every living kakapo on Earth wears a transmitter, and the team knows where each one is. Every nest that appeared was watched around the clock, often with a small camera trained on the eggs and a person nearby ready to step in. When a female left her eggs to feed, people were there. Eggs that were failing were moved to incubators. Weak chicks were taken in, warmed and hand-raised, then returned. Some nests were given gentle heat so eggs would not chill on cold nights. There were even smart eggs, artificial eggs fitted with sensors, slipped under a female to learn exactly how she turned and warmed them, so that an incubator could copy her perfectly. This was not conservation at the level of a landscape. It was conservation at the level of the single egg, repeated for every egg the species produced. There was a hidden cost to all this handling, and it showed up in the chicks that were raised entirely by people. A young parrot learns what it is from whoever raises it. Some hand-reared kakapo grew up more attached to humans than to other kakapo, and one famous male never fully accepted his own kind at all, preferring people for the rest of his life. It made him a wonderful ambassador for the species and a poor contributor to its breeding. It was one more reminder that every rescue leaves a mark, and that a chick pulled back from death by human hands does not always grow into the bird the species needs. And to push the birds to breed more, the team did something that seemed obviously right. They fed the females extra food. A breeding female needs a great deal of energy. Feeding her should mean more eggs, more chicks, and a faster recovery. So supplementary feeding stations were set up, and the females were given all the extra food they could use. and the population did begin to produce more chicks. Then someone looked closely at those chicks and found a problem hiding inside the good news. They were mostly male. In the Kakapo, the condition of the mother tilts the odds of what she produces. A female in very heavy condition, extremely well fed, tends to produce more sons than daughters. It is a subtle bias that means nothing in a normal population, where food goes up and down naturally and the balance evens out over time. But the team had removed that natural variation. They had given the females as much rich food as they wanted, kept them all in heavy condition, and by doing so had quietly loaded the dice towards sons across the entire species. And sons were the one thing the Kakapo did not need. In a species this small, the future is limited by the number of breeding females. Every extra male is a bird that cannot lay an egg. The effort to speed up the recovery had been steadily producing the wrong sex, and the harder they fed, the worse the imbalance became. The help had become part of the problem. So they changed it. The feeding was cut back and controlled carefully, so that females were supported enough to breed, but never pushed into the extreme heavy condition that skewed the chicks toward males. It was a small adjustment in how much food went into a bowl, and it was the difference between a recovery that produced daughters and one that slowly buried itself under sons. Even then, nothing was fast. The birds still bred only in mast years. Every gain was followed by years of waiting, and the small size of the population brought a deeper danger that no feeding schedule could fix. With so few founders, nearly every Kakapo is closely related to nearly every other Kakapo, and a large fraction of their eggs simply never hatch. A species squeezed through 51 birds carries very little genetic variety, and that shortage shows up as infertility, as disease risk, as a thin margin that never quite goes away. The infertility was fought directly as well. In some seasons, when a valuable female would only mate with a closely related male, or would not mate at all, the team turned to artificial insemination, collecting from one male and carrying it, sometimes across islands, to reach a particular female in the narrow window when it could work. In a bird that breeds once every few years, missing that window means losing not a season, but a large part of a decade. So people chased it, chick by chick and egg by egg, trying to squeeze a little more genetic variety out of a group of founders that had almost none to give. That margin was tested in 2019. It was one of the best breeding seasons in the history of the recovery. A huge rimu mast, a record number of chicks, and in the middle of it, a fungal disease that attacks the lungs began killing birds. Teams flew sick Kakapo to animal hospitals, gave them scans and treatment usually reserved for people, and fought the outbreak bird by bird. They lost some, they saved more. In a species this size, a single bad disease season is not a setback. It is a brush with the end, survived only because every bird was known and watched. And that is the honest shape of this story. The Kakapo did not recover because of one clever idea. There was no single rescue. There was a predator-free island, and then another, and then the endless work of keeping them clear. There was a transmitter on every bird and a person at every nest. There was the discovery that the feeding was making males, and the discipline to pull it back. There was a tree that only cooperated every few years, and the patience to wait for it. Take away any one of these, and the number does not climb. It also does not mean the Kakapo is safe. Every living bird still descends from that tiny group of survivors. The genetic base is still narrow, the fertility problems are still there, and the birds still live on a small number of protected islands that must be defended forever. One stoat swimming to the wrong island, one disease season worse than the last, and decades of work could come apart quickly. This is not a finished rescue. It is a rescue that has to be continued indefinitely, by people who will never be allowed to stop. But the number is no longer 51. By 2022, after a strong breeding season, the population passed 250 birds, the most there had been in roughly half a century. It was high enough that the islands were beginning to run out of room, which is a problem the recovery had never had before, and exactly the kind of problem it wanted. And in 2023, for the first time in almost 40 years, Kakapo were released back onto the mainland, into a sanctuary ringed by a predator-proof fence, returning the bird to ground. It had been driven off long ago. Richard Henry, who tried to move Kakapo to a safe island in the 1890s and watched the stoats undo it, has a strange place in this story. One of the last Kakapo found in the far south, decades ago, was named after him, an old male carrying genes from a population that had otherwise vanished. Through that single bird, the line Richard Henry tried to save more than a century ago is still present in the birds alive today. His idea was right. He was simply 100 years too early, working before anyone knew how to keep an island clear. Every Kakapo alive now still has a name. The people who work with them still know each bird as an individual, still track it, still record its every breeding attempt. That began as a symptom of catastrophe, the thing you can only do when a species has almost nothing left. Now it is something closer to a promise. A few hundred heavy, flightless, sweet-smelling parrots that freeze instead of run, that breed only when an ancient tree allows it, are still here, not because they were fast, or lucky, or hard to kill. They were none of those things. They are here because a country decided that a list of 51 names was not going to become a list of things that used to exist. If you enjoy true stories of animals pulled back from the very edge, stories most people never hear, then like this video and subscribe. In the next one, we will follow another species that the world had already written off. Take care of yourself and stay curious.